No, I just got the camera on.
You know what? I'm
in the middle of class for no reason.
Smart aleck comments.
Yeah, it's recording. Like I said, if you want to redraw the picture, that's fine. Maybe you do something like this to where you, still have the same concept going on, okay? But now, we see at this angle up here, at the top is x over 2. So x over 2 there, and this one here is 7x, correct?
Yeah.
Okay. If these two lines here are parallel, okay, maybe you visualize it this way. I like doing this. I like to extend these lines, okay, and kind of get that normal looking picture that we deal with on a regular basis with parallel lines and transversals, okay? And then what does that tell me about those two angles right there?
They are parallel.
They add to 180. They're supplementary, okay? Lines are parallel. Angles can't be parallel. Yeah, how you doing?
Okay, you do since the denominator is 2, you gotta, I'll just do the problem. X over 2 plus 7x equals 180.
Okay.
And then you have to multiply everything times 2.
Okay, so she's trying to get rid of fractions as soon as possible, so we multiply everything by the least common denominator, and the least common denominator up there is 2, right? Okay. We're going to multiply that by 2. We're going to multiply that by 2, and make sure we multiply this by 2. What happens when we go through this, people understand the idea of doing it, but then they forget to multiply this stuff over here by 2. We do this a lot in college algebra, and I get the people to do this perfectly fine, but then they leave 180 over here, and that obviously throws everything off. But now, when we multiply that out, you get 2x over 2, right? Well, what's 2x over 2 same as? Just 1x. So we get x plus 14x equals 360.
What are you finna do?
I was going to write 180. So that gives me 15x equals 360, right? Okay, so 15 goes into 36 twice. Okay, leaving me, 60 left over? 15 goes into 60 4 times. So x is 24.
Yeah, that's what I had.
You should be able to then come back up and plug the things in to make sure this makes sense. If x is 24, what is this angle here? 12. Okay. And then 7 times 24. Well, 7 times 4 is 28, right? So write the 8 down, carry the 2. So it'd be 168. Yep. Okay, so 168 becomes that angle. And that's the only number of 24 that will give me 12 and 168 to add to 180. For instance, if I go through this algebra, maybe I make a mistake somehow, and I find x to be 20. Well, if I plug 20 back in here, I get 10, and I get 140. Well, does that add up to the 180 that I initially thought I should have gotten? No. So that tells me that somewhere I did some algebra wrong that gave me 20, and I would revisit my algebra. My suggestion to you is that when you do that, when you recognize, hopefully you know the geometry, and you've gotten that covered, okay? And that's all, what we got in red there is the geometry. Everything else is Algebra 1, okay? So if you set the geometry up correctly, but you get your result for x and you plug it back in, and that plugging back in doesn't verify your geometry, the initial concept that you thought, then you've probably made a mistake with your order of operations down here. Don't just erase it or get rid of it as fast as you can or crumple it up and throw it away. Analyze that work, because a lot of times what I see people doing is that they get 13x here instead of 15x because they subtract them. Does that make sense? Or if they're moving something across the equal sign, maybe it's like a plus 10, they got to move to both sides, so they subtract 10 from both sides. A lot of times they add it instead of subtracting. There's little small mistakes like that that can be fixed really quick. All right. So don't just scrap everything right away and say, I messed up, I want to start over from the beginning. Usually if you analyze your work a little bit, you can find your mistake pretty easily. Also, if you're bringing stuff to me to ask, I've done it twice, 3 times, I'm still struggling with it, bring your work with me, because a lot of times we don't have to start from scratch. A lot of times it's a simple mistake in here somewhere that somebody from having a different viewpoint can see, and I can see it because I didn't do it, so I take a kind of different approach to it than maybe you would, and I can see your mistakes maybe a little bit easier. That's how you would do number 10. Any others you want to talk about?
Yes.
What?
14.
14. I'm sorry, that was mean.
First part, but the second part I messed up. Yeah,
Okay.
me too.
Oh, I don't want to look at
Which one is it? Me too.
Oh,
So how do we go about getting Anita to lose her voice like that?
I don't know, she yells so much, I'm surprised she ain't lose it already.
I sing high all the time.
Anita's the worst singer you'll ever meet.
That is very
She's
true.
so bad at singing.
I really am, but you know what? That doesn't stop me.
I know.
Well, that's good. That's good. Alright, so when we look at this, okay, we've got a lot of parallel lines going on here. So it's going to be a good idea to maybe just highlight a pair of them and look at a pair of them. Okay. What's going to happen though eventually is that we do have all the relationships that we have with two parallel lines is going to be true with three parallel lines and stuff like that because of ultimately the transitive property. But I think it's a good idea just to view and think about just a couple of these parallel lines. So maybe I look at maybe that parallel line there and that parallel line right there. Okay? And I look, obviously I got two transversals. I can either look at this transversal here, okay, or I can look at that transversal there. Does that kind of make sense?
Yeah.
Okay? So if I do that, I'm trying to visualize the angles that they are providing us that are created by those parallel lines and that transversal. And the only angle that I see here is that 4x minus 5. Because if I take the picture out, okay, that angle right here, okay, is the only one that is there by looking at, or the only one that I can know its particular value or its expression that represents its value by looking at those parallel lines in that transversal. Does that kind of make sense?
Yeah.
So I need another angle to make a conclusion, right?
Yeah.
So maybe those two parallel lines weren't the best to look at.
They were.
And so this thing's providing me issues again. There we go. So bring that back in, and now I'm going to look at that parallel line.
Yeah.
Okay? Now hopefully that makes a little bit more sense because now the 4x minus 5 is made with that top parallel line and that transversal, but the 3x plus 11 is also made by the bottom parallel line and that transversal. So we're looking at that angle there and that angle there. If I remove the picture, what kind of angles are those two angles? Corresponding. So they should be what to one another?
Equal.
Equal. Okay, so we're going to say 4x minus 5 equals 3x plus 11. Alright, so x equals 16, right? Okay, so x is 16. Now, if I know x is 16, can I go back and can I find the values of these angles?
Yes.
Okay, so what's 4 times 16? 64. And what's 64 minus 5?
61.
No.
59.
59.
Okay.
I thought he said 66.
So those two angles are both 59, right?
Yeah.
Okay. So now we got to find y. All right. And if we're going to find y, we should probably have to use an angle that is expressing y, right? Or using that variable in its name, or not its name, but its expression. So let me clean some things up here. Now I'm not going to look at those parallel lines because there's another set of parallel lines here that are going to be useful. And that set of parallel lines is that one and that one. Would you guys agree that if I look at those parallel lines in that middle transversal, okay, that this angle of 4x minus 5, which we now know is 59 degrees, and this angle here of 3y plus 1, if I look at those, what types of angles are those for those parallel lines and that middle transversal? Careful.
Same side interior.
Same side interior, okay, because they're both on the inside. Okay, so if they're both on the inside, they're same side interior, what's the relationship between them?
Equal.
They're supplementary. Good. So we'll say 3y plus 1 plus my 59, so that's 60 there, should equal 180, right? Move that 60 over, so I get 3y is equal to 120. Y ends up being 40. Alright? So a lot of times you're going to have to kind of exhaust all your parallel lines and all your transversals to help yourself out. Now, that's the thing, is that you might look at one set of parallel lines and one transversal, and they don't gain you any information, like that first set we looked at. Okay? So you know that they're going to provide you enough to get the problem done. So look at a different set of parallel lines, a different transversal, or a combination of the two things, and hopefully that'll allow you to kind of progress through the rest of the problem. So that was, what number was that?
10.
14?
14. It was 14.
All right, so I'm thinking, I want to talk, before we run out of time,
We always talk about that last one.
about 15, 16, and 18. Okay? Hopefully you realize this one here was one very similar to what we did in class yesterday, right? Okay, so hopefully that was something we could get done. This is similar to what we did in class. So is this one. Okay, and then you saw things like this in Math Excel the day before. But I want to talk about these two, because these two end up creating some algebra that we need to kind of brush up on, as well as this one. Okay, this one is probably 18. I thought was probably the hardest for you because of the exposure to that type of algebra. Last time you saw that might have been last May, if not before. That's a month.
Oh, is it really?
Yeah.
Never would have guessed that.
All right, so we look at these. So this is number 15. And we start looking at trying to find x and y. So we're just going to pick out some parallel lines. Okay. My hopes are is that you realize that that parallel line there and that one there are probably not the best two to pair up and look at, because do they have a common transversal?
No.
No. When I say common, I mean something they share, right? They both don't share the same transversal. Okay. We actually have to take this one and extend it beyond, okay, that transversal and extend it beyond that point right there to see that it does eventually intersect that line up there. But we don't know any of these angles over there. So there's really not, the way the picture's been presented, there really isn't a common transversal for those two. But is there a common transversal for those two?
Yeah.
Yeah, and that common transversal is right there, right? Okay. So, if I think about these two things, 2x plus y and 120, and remove the picture out of this. If I remove that picture, it's like I'm redrawing it, right? Redrawing it just with the information that's important to me to solve for a particular quantity. What do I know about those two angles? They're same side interior, so they should equal 180. So we say 2x plus y plus 120 should equal 180, right? So what is, we got an equation, we know it's true, so that's the geometry. But the algebra tells us what about that equation? Yeah, it's not easy. One, it's not simplified, but two, it's not easy to solve, is it? Because you got two variables. The only way I can solve that equation is if I know what y is or if I know what x is, okay, numerically. And I don't know that, okay? Now we do have the ability to, rewrite this as maybe 2x plus y equals 60, right? Subtract that 120 from both sides, so you can do that. And you've got some other options. You can isolate y, you can isolate 2x, you can do all that kind of stuff, or isolate 1x. But maybe initially, just leaving my variables on one side, moving all my constants to the other side might be something that's useful to us. And we'll go from there. So hopefully we realize that once I have an equation and I know it's true, the goal is to find another equation that is true that has the exact same two variables. Right, we're going. That's why we're setting it up that way. We're trying to use elimination. So then, if I look at that line being parallel to the middle one, that transversal, we have 2x minus y here. We have 140 there. Remove the pic. Oh, grabbed the wrong thing. Remove the picture. What do you see with? What do you see with those two angles? 2x minus y and 140. They should be supplementary as well. So we're going to say 2x minus y plus 140 is equal to 180. Okay. And now, because we've developed, back in there where it goes, we've developed two equations that have the exact same two variables. And, I'll simplify this one a little bit easier. 2x minus y is equal to, subtract 140 from both sides, So I get 40, right? Okay. So we've got that equation and that equation. They both have the same variables, right? So what we're going to do is we're going to take them and we're going to stack them on top of one another. Make sure your x is aligned, and make sure your y is aligned, and make sure your constants align. Okay? And then we're going to add them. Okay? And now this one, do I have to manipulate any of the equations so a variable cancels out? No, we've already got opposites here for y's, right? So I'm going to get 4x. Those go away because they're opposites. Is equal to 100. X becomes what? 25. Okay? Now, if I need to find y, because I found x and I need to find y, of all the equations that you have developed in any one of these systems of equation types problems, whenever you solve for x or you solve for y, whatever variable you find first, you can plug that back into any equation that you started with to find y. So I'm going to plug that back into this equation right here. Okay? If x is 25, so that would be 2 times 25, right? So that would be 50. Okay? Plus y equals 60, correct? So what's y going to be? 10. Okay? Now that is using elimination, right? Okay? Well, we could do the same problem. We can do this exact same problem. Clean things up a little bit. Oh. My touchscreen's all messed up. Using a different technique. If we start with those two things, can you solve one of those or maybe even both of those equations for y pretty easily? Yeah. So what if I just did this? I said y, let's go to that first one. Y is equal to 60 minus 2x. Is that fair to say? Okay. So now if I know what y is, can I come into that equation and replace that y with 60 minus 2x?
Yeah.
And if I do that, I get 2x minus, now I'm substituting a singular object with a quantity. So I need to subtract the entire quantity, and that's something people are going to use this route they forget to do. And that should equal 40. So that means 2x minus 60 plus 2x. I got to distribute that negative through. Is equal to 40. Okay, so add my x's together, move my 60 over. Do I still get x to be 25? And if I get x to be 25, come back up here, it's really easy to find y then. 60 minus 2 times 25 is 10. Okay? Not the only way you could have done it. We still could have done this. We could have said, I solved this one for y, that red one for y. Can I solve this blue one for y pretty easily? What if I rewrite this as 2x is equal to 40 plus y? Is that okay? So 2x minus 40 would equal y. Is everybody all right with that? Well, if that equation is equal to y, and that equation is equal to y, what can you do? This is something we've done in a lot of proofs. What can I do with that part and that part? Yeah, put them equal together, or to one another. If they're both equal to y, then they're both equal to one another, using, again, substitution. These are just varying ways of substituting. What can I add 2x to both sides? Get 4x over here. Add 40 to both sides. You get 100. X is still going to be 25, right? So I think that's the nice convenient thing about algebra, is that once I create my equations, there could be 2, 3, 4, 5 different ways to arrive at the same solution. Now, there's only 2 techniques. There's either elimination or substitution. But you see in the substitution method, you've got a handful of routes you could go. I think at times it's very important for you to recognize as you're doing tests, as you're taking the ACT, as you're taking, and of course exams, even as you're taking chapter tests in here, to be efficient. Don't choose a technique that might take you 5 minutes over a technique that might take you 2 minutes. Does that make sense? Because you want to be able to kind of start accruing extra time for the end of that test that might get a little bit more difficult as you move on. Let's do the last one. We got time? Yeah, we got time. If we do the last one, 18. Huh?
She said, shut up, we might not even have homework. I said, we'll have homework.
Well, we will now.
You knew you was gonna give us homework anyway.
All right, so I gave you kind of a description of what you needed to do here, right? It says you'll get 2 answers for y because of the power of 2. That's what's going to happen is that every time that you get like an x squared or a y squared or whatever your variable is squared, you will solve it and you'll get 2 solutions. Now, those 2 solutions a lot of times are different, but sometimes they could be the same. So I could get 5 2 times. I could get 12 2 times sometimes. Okay, but there's still 2 solutions. All right. It says in order to solve this one, first use parallel lines to solve for x. Then use that idea, use the idea that there are 180 total degrees in the 3 interior angles of a triangle, so you can solve for y. So I give you a little bit of a motivator there, to kind of help you kind of progress through there to find y. Yeah.
Okay, so 2x is equal, I said 2x equals 68.
Okay.
And then y then, which is x, equals 34.
Yep.
And then I substituted 34 in for the 3x minus 15. Because I did
Yep.
3x minus 15 plus y to the second power. And then
So you get like y squared.
I eventually got to, I don't remember how, I just like, I
Cheater.
simplified and got 155 plus y to the second power equals 180, and then I subtracted, and then I got y to the second power equals 25,
Yep.
and then divided, like, and then I knew it was negative.
Okay. Good.
Sure.
All right. So we're looking at that parallel line there, right? Cut by that transversal. We recognize that angle and that angle should add up to, should be what to one another? They should be equal. So we're going to say 2x is equal to 68. So then x ends up being 34. Okay? So this problem, the reason I gave this to you is to show you its application in something that we're going to do in a couple weeks. So you see maybe a purpose of having this knowledge about parallel lines. Because now, if I have that x to be 34. What's 3 times 34? What's 3 times 4? 12. What's 3 times 30? 90. Add those together, you get
182.
102.
102.
102. Okay, so that angle is 102. Okay. Now you've got, if we look at this triangle, either whether we look at that triangle there, or we can even look at that triangle there, because if that's 102, is this angle right here also 102?
Yeah.
Yeah, so we've got corresponding angles there. So we've got a couple options here, but basically looking at this triangle, and this is what the description here says, and you guys probably know this maybe from 7th and 8th grade, if I take the 3 angles of a triangle, they should add up to what?
180.
180, okay? So I'm going to take 68 plus 102, that gives me 1 what? 180, doesn't it? 170? Yeah, that's terrible math by me. So we got y squared plus 170 should equal, I never subtracted my 15. Man. So we had 102, I know I make mistakes. I had 102 minus 15. What's 102 minus 15? 87, right? Okay. So we had 87 right there. That's what that measurement is, not 102. So that one would have been 87 as well. So now it's 87 plus 68. That's my 155. Okay. And those 3 angles, so the 87 plus 68 plus y squared should equal 180, correct? Okay. Now this is, we did one of these questions yesterday in class where we had to factor using products and sums, right?
Yeah.
Okay. You could do that here, but it's a lot easier to do this. It's called the square root method. I can isolate my y squared and get 25 on that side, right? Okay. So then and this only works if you have just a y squared or x squared by itself. You cannot have another variable in the expression or the equation. Okay? But now I can take square root of this side. Take square root of y squared, the square root and the power of 2 are inverses, they cancel each other out. And then over here, you get positive and negative 5. Okay? Whenever you take the square root of something, you get 2 answers, right? Okay? Now what we want to do is we want to make sure, does this work? Does this make sense? Okay? Well, if I plug in y to be positive 5, Because when you get multiple answers, the algebra doesn't know the context of the problem. The algebra that we just did not know it came from a triangle. Does that make sense? It doesn't know that it represented angle measurements. So when I have y to be positive 5, I square it and make sure I get a positive angle, 25. Does that make sense? If I try negative 5 and I square that, do I still get 25?
Yeah.
So both answers of positive 5 and negative 5 work.
How did you get the 155?
We took, because we've got, let's see here, these three angles should add up to that 180, right?
Yeah.
And we've got these two, which are 68 and 87, and we add those together, it gives us the 155.
Okay, and then how did you get the 25?
So I just moved the 155 over.
Oh.
So that is factoring, and we're kind of running out of time here to show you the way we would have done it yesterday. But we can still do what we did yesterday. If we have, whoops, that's terrible. If we had y squared minus 25 is equal to 0, because that equation there says the same thing that y squared equals 25 said. Okay, you remember seeing that last year? So we know what that's called? What kind of number is 25? Perfect square. Okay? Well, y squared represents a number, right? So y squared is also a perfect square. What is the word that we use for subtraction that starts with a D?
Division.
No, that's division.
Divide.
Difference. So you got perfect squares and there's a difference. You guys remember the phrase difference of perfect squares?
No.
You remember doing this last year?
Okay, that's.
Oh, wait.
We did
yes.
that
That's-
yesterday.
Yes.
So you put, if it's difference of perfect squares, you put a 5 there, put
Yeah,
5 there.
Equal.
One's positive, one's negative, right? If I solve those two individual equations, y plus 5 equals 0, y minus 5 equals 0, do I still get 5 and negative 5?
Yeah.
Yes. Okay. And the idea is that we're looking for two numbers that multiply together to give me negative 25 in that case, but add up to give me 0y. And 5 and negative 5 multiply together to give me negative 25, and they add up to give me 0. Okay? So there, you could have factored the way we saw that example yesterday in class. No homework tonight.
Wait,
What?
Huh?